Welcome to the Think2Think Research Group meeting. So I'm wondering what the arrival distribution is this time. People are still coming in by the virtual door.
Sorry, I'm late.
Okay, we have waited two minutes, which is the half of the official IETF 4-minute standard delay, but let's start anyway. So this is the Think2Think Research Group. Carsten Burman is me, Ari Karanen is there as well. Ari, can you show your video? Because I don't have video this week because my wife has the video capable set up for doing exams.
Yeah, and also Corona has reduced my capabilities of doing video, so I picked the finest side.
Yeah, okay, it's an interesting
I tried testing screen sharing, but it wouldn't let me in the test setup, so hopefully it works.
Yeah, you need a chair to enable the screen sharing. So the too bad we weren't there when you tested. It will work, and otherwise I have a backup. Okay, so I need to do the slide advancing in the right window. This is my version of the NodeWell slide, which tells you that you may be recorded. Actually, you are being recorded. We try to be nice and professional, and the IPR guidelines, the intellectual property rights, if you like that term, guidelines of the IETF apply. So you can go to the link shown there to find out more details. But there's actually a long version of that, which you all are reading and understanding now, so I can move forward to code of conduct and anti-harassment and so on. And okay, so that should be the formal part. Let's quickly talk about the goal of this meeting and of the IETF in general. The IRTF is a parallel organization to the IETF, which focuses on longer-term research issues related to the internet. So the IETF creates standards, and we hopefully create good research or help create good research. We are not doing standards here. And yeah, there is an RFC where you can read more about that. So who are our note takers today? There is a Cody MD, which is on the slide.
Yeah, so I'll be taking notes as usual, but everyone feel free to join the Cody MD and chime in on the note taking.
Okay, we currently have 4 people in that Cody MD, so a few more would be nice. There is a Jabber, which is also visible as the Meet Echo Chat on the left side of the screen. We have a mailing list, and we also have a repository for each meeting. So in the GitHub organization T2TRG, you find repositories for each meeting and some additional repositories. And the one for this meeting is, as convention conventionally called 2021-IETF 110. So let's look at the agenda. Intro stuff is what I'm doing right now. There will be a couple of reports from various activities, including Wishy and the IETF Wishy Hackathon we just had. And then we will have updates from various organizations, this time from W3C Web of Things and from 1DM, One Data Model. And at 1650 UTC, we will actually move to contributions. Michael Richardson will talk about the taxonomy of operational security. Xavier will talk about progress in the IoT Edge document, which already is a research group document, so we hope to publish this one soon. And Mohit will talk about the bootstrapping terminology, which has been around 10 years now. It just had its 10-year anniversary in various forms, and maybe it's time that we adopt it as a research group document and finish it. And the whole timing is based on the idea that if there is a good discussion, we don't want to curtail that just because the agenda tells us so. So we have 20 minutes of flex time we can sprinkle on the various items. Any comments on the agenda? Okay. So let's talk about the research group for a short time in case new people are here. What is the point of the Thing2Thing research group? Well, the point is that we have a large number of standardization activities in the IETF that are related to the Internet of Things. Depending on how you count them, there's about 15 to 18 working groups right now, and a few have already been closed because they have done their job. What the research group actually is trying to do is look at the whole forest and not just the trees that the working groups are looking at, and see what is needed to make an internet where low resource nodes, things, constrained nodes, cyber physical systems, and so on can communicate among themselves and with the wider internet. And of course, that's a very big area, so we focus on issues where there might be opportunities for IETF standardization, and it really starts slightly above layer 2 and ends at application layer, security functions, possibly even user interface. I think we had a proposal at one point to actually collect icons that would be used in a user interface for IoT things. I think that's something we should pick up again at some point. So visually, if you look at the way the IRTF and the IETF interacts, the IRTF Thing2Thing research group is at the top. Of course, we also interact with other research groups, which is not shown on this picture. But we interact with other groups with working groups in the IETF, and there are the actual engineering working groups like Core, which has been doing COPE related protocols, and a more recent one is ASDF, which is engineering a format for supporting IoT model convergence in the sense of consolidation and transformation. There are also some groups in the IETF that also are more on the informational side. So for instance, there is the ELWIG group, which has recently completed, for instance, some really interesting work on getting the right ECC curves out there for constraint devices. They have looked at TCP for constraint devices and so on. So that's what ELWIG does. And there is a very new thing called IoT Ops, which is discussing operational issues, which often are security issues in the end. So it's a very interesting group to interact with. The meetings we are trying to organize are summary meetings, like the current one, where we try to bring things together. We also have been having regular wishy calls, work on interoperability. What is the expansion? Something with interoperability, hypermedia, and something, where we meet approximately monthly and discuss various things. That has been paused for a while and is now picking up again, and I expect that we will do this monthly again. Then we have interaction with various other SDOs that use IETF products or that are related to IETF products, like OMA and OCF and W3C. So whatever we want to do there is usually organized around a specific topic that we want to advance. We probably will have another summary meeting at IETF 111. And one thing we haven't quite figured out yet is how to do online co-locating with academic conferences. Now, online co-locating is apparently doesn't really make sense as a term, but so how can we interact with academic conferences during the time of the pandemic? So maybe we don't have to actually learn that, because the times of the pandemic will be over at some point, but maybe it will drag on for a while. There was a question in the chat that I missed. What about LPWAN and SCHC at the COAP level? Interesting questions. Again, there are 15 working groups that really do stuff that is IoT related, and if people want to bring up things that have more researchy perspective to them, please do just send a brief message to the mailing list and we can start the discussion. Okay, and finally, we might have a physical meeting at some point in time. Again, these usually have been quite productive, and maybe Madrid is the first time we can do that again, but let's see how that works out. So if you have a calendar, maybe mark the week before Madrid as a time where we might be doing that. There are several documents that are research group documents that we have adopted. The RESTful design for IoT document has recently got a terminology update and probably needs one more pass before we can sign this off. We will talk about the edge computing and IoT document today. And I think the document is pretty much cooked, but we need a few reviews to actually decide this is ready for publication. We have a secure bootstrapping for IoT document that, as I said, has been around for a while and we probably should be adopting. And also there are some non-internet draft documents called Wishy Notes, which are collecting at the Wishy Wiki, and that's also activity that should be ramping up again now that we are done with our ASDF support activity in Wishy, which kind of occupied much of 2020. We also have a very interesting new submission that we will talk about today as well. So Wishy, yeah, that's the expansion, sorry. Work on IoT semantic hypermedia interoperability. So this is where semantics, data models, hyperlinks, and similar things go. So as I said, we have been trying to help the ASDF working group get off the ground. That is a done deal now. Actually, the ASDF working group has completed its first deliverable today. So we haven't published an RFC yet because we still want to work on the SDF format, but we have, after 1DM brought us working SDF 1.0 version, we have managed to actually get a 1.1 version agreed today, and that will be ongoing, but it will no longer be an IETF activity. We are looking at the various standards in this space, in the semantics and hypermedia space, and we are really interested in describing them. So finding out how do these things fit together, where are they similar, where are they doing very different things, because it's really hard when you learn about a new thing, actually penetrating the marketing materials and finding out what it actually is. And we actually had an online Wishy meeting since the last IETF, and also an AST Wishy hackathon I will talk about. So what was that hackathon that happened last week? And it was joint work between ASTF and Wishy. There were about 7 people actively contributing. So we had 4 things on the agenda. One was focusing on validating SDF 1.1 and essentially preparing the decision that was made today to label the current version as SDF 1.1. And of course, the tools and models that are still SDF 1.0 need some attention to move them to 1.1. Michael Costa produced a very interesting Modbus example that tells us how to include ecosystems that are very much focused on registers and bits and so on into this space. We actually defined some part of SDF 1.1 that was just missing, the fragment identifier considerations. And we also identified a problem with one component of SDF 1.0 that we are going to work on in SDF 1.next, but that is not currently part of SDF 1.1. And we also had an interesting discussion about the compact notation for SDF. The second activity was on the semantic proxy work. So we have various converters, and the hope is that we are able to use these converters to connect different ecosystems, clients and servers from different ecosystems, and have that connection guided by common SDF. Obviously, we need some additional functionality there, which is called mapping files here, but we already have some interesting demos out there. The third item was new tools for SDF, and one interesting tool is the SDF thing maker that simply assembles SDF things out of SDF objects. So we are now starting in earnest to get tools that operate on SDF models and build new models out of existing models, and that's certainly something that is worth some research. And finally, we discussed mapping files, which are a way to add information to an SDF model that might be ecosystem specific, so like IPSO or Zigbee or Bluetooth, or might even be instance specific. And one aspect is how to add protocol binding. So you have some abstract property in the SDF model, but at some point you need to know what the actual URI is, and Jan Roman provided an interesting proposal there. So that's my summary of the hackathon. I'm not watching the chat very attentively. Okay. Yeah, with that, more updates, and I hand over to Milan.
So it seems Milan had some technical challenges. I'm not sure if he managed to join yet.
Okay, so maybe we just push this to a later point. I don't see him in the participants.
Yes, let's take this on a later slot
Yeah.
when we have Milan joining.
Thank you. So I think that completes the chair's part of the overview, and we can now move over to Michael McCool's presentation. Michael, can you share your screen, or do you want me?
I'm unmuted, and we share my screen. So if you see more than one screen, please select the presentation. Second. Here we go. Great. Okay, so I already typed in some stuff into the notes. So for follow-up, be aware there's some URLs and things that I already typed into the script. I'm just going to quickly go through, this and see what we can do here. So the Web of Things is a W3C activity, which, as you probably know, focuses on web technologies, mostly the browser. But the WOT activity is focused on IoT and is focused on applying those web technologies to IoT. And we didn't want to create a completely separate vertical stack, because one of the big problems with IoT is the proliferation of different silos. So instead, we tried to identify a gap, and the gap we identified, this was 3 or 4 years ago, was the lack of documentation between different standards and how to connect different things. And it was very hard to use a system if it wasn't well documented. And we wanted to see the gap we saw was actually a need for formal documentation of the capabilities and way to access a system. And we also want to create kind of a common abstraction layer. So what's been already published from Web of Things is a metadata format, which basically describes the network interface for a thing and kind of maps it to an abstraction based on properties, events, and actions, which, if you're aware of SDF, is a very similar model. And in fact, it's closely aligned with the SDF activity, separate but aligned. And so the idea here is, as I explained in the diagram below, is rather than having to do an n squared, end to end, every app supporting every possible protocol, instead, every app could support a common abstraction in terms of, kind of a generic interface. And that abstraction is going to be mapped to various protocols. But you still, we're not trying to create a new protocol that does everything. Instead, we're trying to create a common description language so that apps can easily, use protocols directly, but through an abstraction. So we do think that the common protocol for everything, is a ship that has sailed. That's not really feasible at this point. There's too many protocols out there embedded in the world. So instead, we're just aiming at having the common abstraction as the narrow ways. Now, I just want to give a brief example of what a T looks like. So we are, again, focusing on describing existing systems in a thing description. So we're not trying to be prescriptive. We are trying to support, there is some recommendations for new devices that are written from scratch, but we also want to have the ability to support brownfield devices that are already deployed, and you just want to figure out how to talk to them, you want to document them, and so you might deploy a thing description. And the thing description might be supplied out of band, so the device doesn't even have to know about it necessarily. But we're also looking at extensions for more like smart object concepts or directory concepts, where devices know about what and can more directly participate in, for example, distributing metadata. At any rate, the thing description is this JSON-LD file, and it includes properties, events, and actions. There's an information model for it, and technically, JSON-LD is one possible serialization of the information model for a TD, but it does mean that it's easy to ingest into things like an RDF database and then be able to do things like semantic searches on it. So, which is kind of the next point here. And well, let me just talk about where we are with our process. So we published a bunch of standards. Well, we published the thing description and the architecture in January, technically, January last year. And now we're almost at the end of our second charter, where we're doing several updates. We're updating our thing description, and we're updating the architecture document. But we're also developing some new standards in discovery and profiles. And discovery is really about, okay, how do I find metadata? And it's not just about land discovery. It can also include things like internet search, or I give you a URL to tell you how to get a TD or whatever. So it is a more general concept of finding metadata. And it also has a strong emphasis on privacy preservation, which is one of our major constraints. And profiles is more about constraining the implementations a bit so that things work out of the box. There's also some updated documents. Binding templates is very similar to the problem of mapping that Michael Costa was bringing up, is how do you connect an abstract TD to a particular protocol like HTTP or MQTT. And the scripting API is a JavaScript API that has an open source implementation in Node.wat, makes it easier to use the abstraction. The most important link on this page is the last one. We just launched a new website, and so all this stuff will be available from that website, which hopefully is fairly easy to find. If you just type in W3C and Watt, you'll find it. Now, so I think that that's basically the summary, and I think that to mention a bit more about discovery. Discovery is one of our major new things. Oh, I guess I should spend the timeline. So we're currently finalizing our draft with the intention of having solid first drafts end of March, and then we want to have complete drafts ready for review by May 1st. And we're looking at entering the formal process of turning it into a standard within W3C at the beginning of July. So between May 1st and July, we'll be open for review, and we can still make changes at that point. But then after the July 1st deadline, it's really hard to make changes. So that's kind of the window that we want to target if people want to look at our standards and contribute. We do want to kind of wrap things up in the next few months and stabilize these. I should also mention for thing description, we're starting a thing model. And the thing model, so thing description is about an instance of a device. A thing model removes instance particular definitions like particular URLs or network addresses. So they're close. Thing models are closer in concept to SDF files, and there's been some exploration about converting SDF files into thing models. And to go to a thing description, you also need things like a network address. Okay, so that's the update. I will stop here, and if anybody has any short questions, and then we can check the time and see if there's anything left. Okay, I'm not hearing any questions. But, okay, well, I guess maybe we can move on, but if anyone wants to follow up, we do have a face-to-face next week, actually the next 2 weeks. And if you would like to attend some of the open sessions, send me an email, and we can bring you in as a guest. Otherwise, the webpage and the specs are out there at these URLs.
Yeah, thank you, Michael. There are some pretty good links in the CodeMD in the notes document. So if you want to know more about these activities, or want to find out what's happening in the next few weeks, please look at the notes. And there are links you can click on. Unfortunately, you cannot click on the links here in the slides that we are looking at. That's a limitation of MeetEcho.
Right. But again, they're in the PDF. They're clickable in the PDF, and they're also clickable in the notes page. So. Right.
So, any more questions for Michael? In which case, we can switch back to Milan, who has made it onto MeetEcho. So I'm taking away your screen, Michael. Thank you. It always takes a slight dance. to do this. Okay, Milan, go ahead.
Yeah, good morning. I'm Milan Milenkovic from IoT Sense, calling from California this morning. And this is a brief update, about 3 minutes, on the paper and activity that we are starting in describing the IoT standards. Can you get the next slide, please, Karsten? Oh, can I move the slides? Okay, great. And so basically, we have had the discussion for a while in T2TRG research group and basically in Wishy meetings to create a paper, probably in the form of informational RFC, that will describe key attributes of IoT standards, nothing new there, and information models, but in a consistent manner. Basically agree on the structure and the concept and how they are described, and then allow standards to be described in a consistent manner. This is important and potentially useful because different standards group have different assumptions, some of which are articulated, some of which are not. They have some implicit point of views that are not clear. So it's very difficult for somebody from outside to understand the landscape by reading the charters or by reading introductions and architectural documents and be able to compare as to what they do and what the objective is and how well they may suit the needs of somebody who's trying to either adopt them or work with them or just understand them. So what we are looking for is trying to do a sort of high level description, but provide some structure and almost like the checklist of what is the intent, what is the purpose, the scope, and the approach, using some common terms and criteria. And in doing so, define the terms and articulate the concepts and assumptions, not the implicit assumptions, or everybody in the group knows. It sort of becomes group knowledge by osmosis, but it's not always obvious in documents. The intent is definitely not to re-describe these standards, to rehash their specification. The intent is to foster the understanding. So probably a relatively good analogy to think about this effort is like making an IoT information standards labeling guide. Like you have the food labels in terms of nutritional content and calories and various other things, agreeing on what is the structure of the things to be described and how they are quantified. Obviously, we wouldn't be quantifying them here, but we would provide a common basis for comparison. A stretch goal, which is, we'd like to do it, we'll try and see if we succeed, is to get some of the important ongoing standards described in this manner, or at least the intent and concept described, obviously not the specification itself. And we would rely, initially we were going to do that as part of the paper, but it turned out to be rather onerous and probably prolong it in practical length. So we will seek contributions from STO participants to do that. And my final slide, please, Karsten. So the current status is we have discussed in an earlier meeting in June in T2TRG, strawman of what the common description criteria need to cover, what are sort of the items we think would cover, and that's available as a document at this link. And suggestions are welcome. It can give you an idea of what's the outline of things we will attempt in this effort. The outline, the first sort of draft that puts everything down, not necessarily obviously in the final form, is planned in about 6 to 8 weeks, and I'll take the lead on doing that, and of course welcoming contribution and co-authors. It will be made available for review and comments initially in T2TRG working group, so that we bring it to a more mature level before sharing it with others. As I mentioned, contributors are sought either now, although this is a very fuzzy description, but you can email me and we can interact, or after the first draft, which I said is going to be done in about 6 to 8 weeks. Both contributors in terms of ideas and concepts as well as co-authors are solicited. If you have also done, there are several floating comparison of applicable standards that will contact the authors and see if they want to participate, and obviously they will be incorporated as references into this work. And in terms of actually describing standards along this line, I know we have discussed earlier, both Michael Costa and Michael McCool have done some more detailed feature analysis of various standards and comparison, and I'll work with them also, and we'll work together to incorporate those as well. This is basically a very brief update that I wanted to give you on this activity, and obviously when we have the first draft, it's going to be more tangible and something tangible to discuss. So that's basically my update, and I give it back to Carsten.
Okay, thank you, Milan. So I'm going to click this link because I can. No, I cannot. Oops, normally. There it is.
Yeah, it is.
Yeah, so you find more information in the GitHub repository that Think2Think Research group uses, and in particular in the Wishy part of that. I just wanted to point that out for people who want to see what has been done there here already. Okay, thank you, Milan. Any questions? Thank you. So in this case, we are on time. The next item is Michael's presentation. Do you want to present, Michael?
Share. I put the request.
Yeah.
All right. You get that? And we can just run the slide from here. Do you see it?
It's working on it.
Yeah.
Still working on it.
I'm not getting a dialogue, but let me go out of full screen and see if I got a dialogue somewhere asking me to approve something. Yeah, let's see. Yep, I had to click a green button. Oh, and I have to open my system preferences. Well, let's see if it'll let me just click on something, or otherwise I may need to.
Yeah, maybe I should do the sharing. So
yeah, maybe you need to do it because it looks like I have some dialogue to go through.
yeah, it's always dangerous to update your system. Michael actually updated his system the night before the meeting, and that's always fun.
I learned why it was that I don't often update my system, but the longer you wait, the more painful it is. And basically every application now acts like it's brand new. And anyway, great. So this is a summary of what we've been doing with one data model mostly, and some other related things also. Next slide, please. Our goal in one data model was originally, or is still mainly, to normalize the information models for IoT pretty much across industry, information models and data models. But it really is an information model focus. We call it one data model. I think maybe some historically that most people recognize that, and saying information model is more correct, but you know, it brings up some questions. So it seems like, you know, we're all right this way. What we ended up really deciding to do was really kind of refine that mission a little bit, and what we're providing for really broad semantic interoperability across industry. We want to converge the existing models, and we want to create a system of interoperability and reusability at the semantic level, among other things. So it started as a liaison group between SDOs, and you know, we have Zigbee and OMA and OCF and Bluetooth Mesh and some other more vertical oriented ones. And we decided to focus on a representation language, a modeling language, or a domain specific language for this work. And that the outcome of that was SDF. So I'd say that the SDF prototype, which we call 1.0, is really our phase 1 work product from one data model, and that sort of got transferred over to IETF the middle of last year, and we were toward the end of last year. Next slide, please. The current status is we have about 200 examples of object models, which are the main sort of reusable building block. It's a slice of functionality, like turning something on or off, and or changing the color. And so a typical product will have a set of these object models to describe its full functionality. But we have 200 of these, mainly the whole catalog of OCF and EPSO smart objects, minus a few that are kind of corner cases. And then a few examples from Zigbee and Bluetooth, but we haven't done any wholesale conversions from those catalogs yet, but that's in the future. We have automated tools that have been built by folks on the call here, mostly converting from OCF and OMA back and forth around Trippable to and from SDF. And that's where all those 200 models came from, is through some automated conversion. New models also can be easily generated in SDF and then converted, down converted if you are targeted toward OMA, OCF, or others once we have the converters. And the whole system then, models can be translated from one ecosystem to another through the standard SDF models. I can take an OCF model and up convert it to SDF, down convert it to OMA, for example. And that allows me to translate from one model to another. Next slide, please. So the one was mentioned, the semantic proxy. This is one use of this ability to translate those models. And this is sort of, picture gets refined a little every time. This is sort of the best one so far. If we were to use, we already have some proxy functionality with Web of Things in a project called Eclipse project called Node Watt. And it consumes, it uses thing description to consume and expose APIs. And so the idea here is to take a common SDF file for something like a lightweight or an OMA or IPSO smart object sensor, and convert it to SDF, and then convert that SDF to OCF, and that provides a Swagger or an Open API 2.0 description that an OCF client can then go use to consume an API. And what we're working on is automatically consuming the OMA device and exposing it as an OCF device for the OCF client, and building a sort of an automated bridge between an OMA, an IPSO device server, and an OCF client. And we have a few ad hoc patches that have been created to sort of, continuity test various parts of this, but this is what we're working for as our sort of first big demo for 1DM, and why you would want your models on 1DM, and one of the useful things that can happen. Other than just everyone converging and arriving at a common set of models, if you want to translate models, this is a great intermediate step. Good, next slide, please. We need to kind of finish up here to stay on time. So going forward, since we have now a stable implementation draft of the language, we're going to go out, reach out to Zigbee and the Bluetooth Mesh folks and some of the others, and start getting contributions in and start working on the conversions, and eventually get going on our convergence process. So we have also a few broader use cases and collaborations we're involved with. Some of this has been mentioned before, but there's a solar energy spec, SunSpec, that currently have a Modbus register definition, but we could add all the semantics to that, and they were interested about a year ago. So we want to get that. So there's some folks doing textile manufacturing equipment contacted us. There's some work being done on electronic data sheets that is closely related. That's they would like to look at using SDF. Again, there's an ISO SC41 sort of it's a little tighter, I guess you'd say. They sort of would want to see SDF be sort of part of that, and not clear exactly how the integration is, and maybe others could explain it a little more. And also we were contacted by the US Standards Bureau, called the National Institute for Standards and Technology, or NIST, in the US, to look at common ways of modeling things, and they were quite interested also. A lot of this is basically just SDF and not really one data model, so we probably need to look at where the center of the collaboration really needs to be for some of these things. So textile and electronic data sheets might be more 1DM, but SC41 and NIST might be more, SDF. And basically, we want to get the convergence process going and start working on parallel tracks where we can separate the dependencies between groups of models. As some group of people want to be interested in pushing one set of models forward, another group, vertical groups, maybe somebody working on lighting, someone else working on appliances, someone else working on energy. And we want to get a 2-week cycle going between work and questions coming up, and then broader review and the broader process. So on to the next slide, please. Yeah, so this is, I'm not going to talk through all of this, but basically this shows that we have existing models, we have new models that are going to be created, and then we have models that are going to be sort of alloys or amalgams of existing models. And those all kind of start off differently, but end up consolidating down to the same adoption process. Next slide, please. Which I'm not going to talk through this either, but essentially models go into a thing we call the playground, where this alloying and this annealing and working off the rough edges and convergence takes place. Then they go through a review cycle, which they can get kicked back from more work, or they can go on forward to a sort of a last call at a model adoption process, where they get published in our official adoption repo. And we're basically just on the leading edge of that. We have stuff in the playground, and we're just about to, as soon as all the Plugfest and hackathons and meetings are over, we'll select a set of models out of the playground and work toward convergence. And I think we have a couple of different verticals already selected to work on there. Next slide, please. So, right, the playground is where the models are converged. There will be separate repositories for contributors. I don't know exactly how it works, but since it's on GitHub, all we really need to do is share the CI, and we can scale it to what we want. They don't all have to be in our organization, but right now we're thinking they will be in the same 1DM org, just for the sake of collaboration. But the contributors will be able to sort of manage their own namespace while they're preparing for contribution. And then there's also some exploratory repositories for testing new features. So it's one repo now. To look at the mappings and extensions and things like that we're doing, and play those out without introducing too many CI issues into the playground. So I think I have one more slide. The references. So basically, go look. We have some stuff you can poke at 1DM, and of course SDF that folks already here all know about already. Thank you.
Thank you, Michael. So 1DM is in the kind of similar situation that they focused on getting SDF going for a while, and now can go back to their own business and actually get models accepted and converged and so on. So any questions to Michael on this?
So, Michael, what's the time frame for you think it's going to happen for getting this all standardized? And do you have any idea?
For what? I didn't quite hear your last bit.
Do you have any idea what your time frames are for like getting these drafts stabilized and finalized? I was in the meeting earlier today, and I know there's some final PRs being discussed.
But now you are
Yes.
talking about ASDF.
Yeah.
Yeah, we finished that, and SDF 1.1 has been posted. So
Okay.
we are now officially in the 1. Next phase in ASDF.
Okay. So
I think it's
basically,
draft 05, right?
right. So now you're in like looking for new features to consider, I guess, round.
Yeah, not really looking for new features. We know a lot of new features that we should be
Right.
considering. So that was actually more than half of the meeting this morning, where we looked at what we already know what needs to be part of 1. Next.
Right. Well, I guess what I mean is you're now in the phase of new developments as opposed to
Yes.
trying to nitpick the release. Okay.
Okay. One question from the Jabber was, are there any links from 1DM to organizations like IP Bliss and CHIP?
Zigbee organization that runs Project CHIP is a member, and a number of the members from Project CHIP were founding members of 1DM. Basically, they have strong enough desire to converge across industry that they worked on 1DM for a while, and then I would say it was part of them being able to find each other to go to Zigbee org and decide to go straight to implementation of of the chip standard as a way to fulfill their commercial interests. But 1DM is the more long-term focus of converging the models, and there's still a desire from Zigbee to do that, although they're now very busy with chip, and they need to get chip out the door before they're going to have significant. But the good news is the models from chip to Zigbee aren't really that much different. There'll be some new ones, of course, since there are new players. IP Bliss, and other organizations like that, I think we have had some contact to the extent that our mission and theirs align. There was some interest, but I'm not sure what going forward is going to be, and I'm not sure if Wouter is on the call. He might be able to say more, but I don't see Wouter. Wouter Vanderbeek is our contact with IP Bliss.
Thank you, Michael. That was interesting. So, more questions for Michael? Okay, Andreas says thanks. Okay, with that, thank you, Michael. And we are moving to the next presentation. Again, Michael Richardson. You already have the screen ready. And I have to press a few buttons to make that happen. Yeah, great.
Good. Hi. So I'm just here to talk about this document, which has been suggested to become a taxonomy of, I should have put the document title in there, I'm sorry, of IDEV ID issues. So this was first presented last summer at Sec Dispatch with a kind of like, I don't know where to send this, what to do with it. Carson suggested that T2TRG would be a good place to this, and so now I'm talking to you. So this is about roots of trust and trust anchors. And these terms are sometimes really confusing to some people, even in the security space, because they are actually, in some sense, they are opposites of each other. So a root of trust is in the trusted computing space is actually usually something that you sign your data with. So it's in fact some kind of a private key that's embedded in a device that's used in some cases for attestation. And that's why it's called the root, where you start with. Whereas trust anchors are public keys that you embed into the device that allow you to verify things that other things people say. And as I said, if you go into the PKI community and start talking about roots of trust, they assume you mean trust anchors, and that's often not the case. So But what we're really talking about is that in both cases, what's important at the very bottom of the process, and there's this allusions to its turtles all the way down, and the answer is, well, no, it can't be. Somewhere at the bottom is a turtle that anchors it all, and that fundamentally is a private key, whether it's in the device or if it's in a manufacturing plant or infrastructure. And one of the things that I've noticed is that when we have conversations about security considerations around other documents, one of the questions is, well, what's the incentive to keep some of this private key private, and who's going to attack what, and how can I really trust it, and what about this manufacturer who didn't do things right? And that's kind of a slippery slope of just kind of disastrous things in a document, because it's essentially asking layer 9 or financial and type questions about a technical document, and we don't really have a good way of answering it. So this was an attempt to kind of qualitatively answer it there. So this is what the document's about. It's about the quality of these turtles. How secure are they? Who owns them? Who controls them? How are they created? And how are they provisioning? And one of the things that you kind of have to realize, and I come back to this at the end, is that if you can change the software, then of course you can change what keys it thinks does what. And so in some sense, the ultimate trust anchor is the one that defines what software you're able to run. So one of the first questions is about the roots of trust. So this fundamentally is an IDEV ID, if you want. It's not always, but it usually is. And the question is, how do you get it into the device? So this means a key pair, a private key pair that needs to be kept in the device. And how was it produced? How was this associated probably certificate created? What resistance do we have against devices which are being signed with the keys that that is inappropriate devices are being signed, and what's the opposite, where devices that you don't know have been compromised and they're still said to be good. And one of the big problems with this is that when you go through the supply chain processes, there's usually 2, sometimes 3 layers of NDAs involved. I'll just mention before I continue that some of these roots of trust, some of these things are in some cases symmetric keys, but usually there's another layer in the supply chain that turns that into a asymmetric key. But you won't find that out unless you signed all the NDAs and know what's going on. So the goal of this document is to ideally to have some kind of a thing that says, you've done the following thing, and I don't really care if you got a certificate from some government body that said you did the right thing, or you have the Cheetos level of security here. Because what I care is that you're able to distinguish those two, and that you can say, I point to the top one or you point to the bottom one. And for some devices, you know what, that Cheetos might be actually all the security you actually needed on your bike shed. That may be enough. So the document has a outline, and it deals with different types of identities, and it deals with a series of evaluation questions that I'm suggesting that I would like to be answerable by things. I'm not proposing to answer them for any specific case, and I'm actually not proposing to even to say what are good values and what are bad values, but here is a value, and we agree what the definition of that value is there. So Sec Dispatch said, go out and ask industry people outside the IETF what's going on. And I've presented at 4 or 5 other conferences or groups in this, and about 4 other one-on-one conferences with various suppliers. And I'm bugging them regularly to give me some kind of replies. Everyone's really interested, but it's not a high priority. Unfortunately, I don't have a lot of feedback for that, but it is the goal to get that through some kind of a process this way, and I would certainly like your help in that. Some of the things that are described in this document is the structure of a PKI. One of the questions is, for instance, is this level 0 or level 1? And the conclusion is that if you just had this PKI and you just had a self-signed certificate, that you actually have a PKI of level with a depth of 1, not of depth 0. The second question is the second level of PKIs. Is that an intermediate CA, or is it a subordinate CA? And after some discussion and reviewing other things, it seems that subordinate is the preferred term, even though a lot of documents will often treat them interchangeably, those terms. If you want to see what an intermediate CA looks like, then follow this link, and you have to go and play with some of the zoom in and out and clicking on some of the things, and you will see the immense complexity which has been created in the US federal bridge CA system through a number of intermediate CAs, and those are quite clearly documented in quite a number of documents as intermediate CAs. And so I'm going to avoid that term, and I suggest you to do. And anyway, subordinate just sounds so cool, I think, as a term. And so it deals with also recovery and resilience, and how are the private keys generated and how are they kept safe is an important discussion that I think you that's usually what we want to be able to talk about in the end. So I've proposed a number of terms. This is I don't know if it's an ontology or not, but it's a series of questions that I would like to know. I would like someone to be able to describe in a way. And the goal, again, is not to say that a 2-level PKI is better than a 3-level PKI or worse or there, but to agree that if someone says they have a 2-level PKI, then you know what it is. And if they say they have a 3-level PKI in which one of them has a secret sharing policy of 4 out of 7, then you can actually know what that means, and you can actually say, okay, that makes sense, and now I can make a judgment as to whether that's good enough. So one of the things that I don't know how to describe, and I'm looking for help here, is, and there's actually some real contradictions here in this part, is one of the obvious things that you want to do with any of your say factory located PKI pits is the private keys that you use to sign the IDEV IDs that go into the device. Well, those private keys, they remain in your factory. And the top level, probably, if you can afford it and you're smart, probably goes into some kind of a hardware security module. That's an HSM. But they are expensive, and it's not always clear to me that they have a specific value. And sometimes they're more of a hassle as well. One of the things you may be interested is to, sorry, I have to close my gather town because it's talking to me for some reason. There we go. So the issue is, if you, for instance, looked at what the root DNS people had to do last summer to essentially deal with the fact that they actually couldn't have a key ceremony due to the pandemic. And so at one point they, under supervision, drilled some of the data out of their safe to be able to continue. And I sort of had said, well, what was the point of having a safe if we could just be allowed to drill it out? And I guess the answer is that we knew that they were doing it. So you have this quandary. On the one hand, it would be a good idea to divide your private information into more pieces and have it more resiliently available, maybe on different continents, so that you can continue to deal with maybe pandemic issues to travel. On the other hand, if you have more pieces, then there's more likelihood that some smaller conspiracy of people could continue to do something else, or the fewer number of people you need to be, the more number of people that need to be resilient to corruption, bribery, or extortion if it's value due to them. Again, the point is not to say what is better and worse, but to understand what are the risks. So if you're buying national ID cards, as Taiwan did 20 years ago, you probably want to know that they have good cryptographic content and that they can't be easily forged. And if they can, then at least you as the national agency hold all the cards to making that happen. I mention them specifically because it turned out that they had issues with their private keys were not as random as they thought they were. And there's a paper out there that you can read. It's quite astonishing. So this is the question: how are you going to describe this thing? How are you going to describe this level? Is this something that you actually want to describe as part of this there? But as an end user, you'd kind of like to know what are the risks to the supply chain. Maybe not for your home webcam, maybe that you think it doesn't matter to you, but maybe you really do care about the pieces that go into your autonomous vehicle, for instance. So as I described before, a great number of this is hidden behind non-disclosure agreements, and you don't really know what's what and who's who, and they aren't likely to get behind that. So that's the goal, is not to kind of to break that open. I'm not trying to say, okay, tell us all your secrets, tell us what's going on, but rather that when you hire an auditor or the company has provided you with audited results, that you can actually read the audit results in an intelligent way. And this has kind of input into the rest of our security considerations, other documents, where you may actually have to say, well, this is the kind of thing that I would expect this level of security in there. And you could go and find out if that actually happened. And finally, I just come back to one of the last little things that I started with, is that pretty much you should realize that every device out there is going to be determined by what software it runs, and whoever determines what software it runs probably determines what the authorizations that are associated with a particular set of trust anchors. So that's the public keys that you built into your device. So if you can change that software, then you pretty much win. And I think this is actually one of the places where if we were to go through a number of audits and things, we would actually be kind of surprised that some of those software signing keys are really not as well secured as we thought. And there was recently an issue with a Microsoft Windows Active Directory Management, a third-party tool, I believe, which had this problem. It turned out that there were possibly access to that code signing key elsewhere. It's unclear from the press release, but the point is that if you got a thing and you have gone through this process of trying to make it secure, and then you hand out your signing key to anyone that asks, then maybe that's a problem. And maybe there's some other process that you need on top of that. But whatever the case, my goal is simply to be able to track in a qualitative way how you do manage that key. And that's about it for me. Questions? And I would really like this document adopted by T2TRG. That would be great. But I also really am very anxious to have additional co-authors and people who would like to take this out to industry groups and provide some focused feedback.
Okay, questions for Michael? Everybody is called Michael in this group. Sorry about that.
Ari, go ahead. I don't know if you're who's managing the queue.
I'll join from the mic line. Thanks, Michael. It's a very, very interesting piece of work. And one thing that occurred to me, I think there's quite a lot of similarities on the work Milan is doing, kind of from the IoT protocol side. You're kind of doing from the security side, establishing terminals and ways to describe things in a uniform way, so you can actually understand what is there inside. I was wondering, maybe there would be some alignment even to be done there, but overall, it's kind of wanted to share this.
Would this fit into SDF? Is that what you're asking in some level?
Sorry?
Absolutely.
That would be an interesting way. I mean, as my goal was not to make this machine readable, but human understandable. But at some point in the supply chain space, you actually do need to make this machine readable, because you get the number of parts that you get and the changes to those parts, or the security properties behind those parts, needs to go through a supply chain. But I wouldn't want to try to write it down before we actually, in a machine readable format, until we had enough examples to make sense of it. 1DM had I'm just amazed that you guys have 200 models already, and I think that's really valuable. So I wouldn't want to do that prior to having at least 20 or 30 descriptions in English or some other language, and before we continued. But I think that's definitely sounds like an SDF 2.0 kind of effort.
Cool, thanks.
Henk?
Hi, Michael. Yes, this is Michael. I'm sorry. I'm very sorry. My question is about slide 9, where you said, I don't know if this is an ontology. And I don't know why you want to know that. So I think it's good to structure things kind of, I don't know, hierarchically, and then it's like a subclass tree in a taxonomy. And that's always, well, that's a first step towards ontology modeling, I guess. with narrower and broader terms, and
Right.
maybe that helps to some extent.
So the reason I said I don't know is that I don't know if there's enough structure to bother. At this point, I'm quite happy to just put a bunch of terms in a bag and not worry about how they relate to each other. And later on, if literally that's all the terms that I have in this thing at this point. When that exceeds 3 pages or 3 slides, then I think it's time to structure it in some way. But I don't know if you look through the document, there are, parts that relate to trust anchors and parts that relate to private keys, but that's just really how they do. So I guess part of the point is that I don't really want to argue about what's similar to what other thing. I just really want to get the terminology down in a way that I can reasonably find out for devices that I own or parts that I want to include in devices that I'm building, how they are managed and how it happens, right? And that some of these questions could be answered.
Okay, yeah, I agree with only models things you need, and not because they're just true or somehow there. So it would be a very boring tree if it's just a depth of 1 or 2 maybe, and then I don't know what's the purpose. But then again, you're at the right place, I think, when you want the semantic dependencies. Like I need the location, and a key is in there, and it can be private, and it's used for, and all these semantic relationships between these terms. That might actually become an interesting thing to consume for other stakeholders. So I would keep that in mind. And just as a first question, so to speak, at the very beginning you were talking about, and I think it's excellent to bring that up, to confuse what actually well-defined things like root of trust and trust anchor. And looking at the document, I think you're not opening that can of worms there, right? You're not introducing the disaggregation there.
There's 2 categories of things that we need to discuss, right? But there's the private keys that are in your devices, which turn out to be your roots of trust, okay? But then there's the private keys which are in your factories, which are not the same thing, but they lead to the trust anchors that are in your devices. So both cases, though, the discussion of how is the private key protected and who had access to it and how was it generated, well, that actually applies to both. Just the types of the answers you get are different, right? Like the number, how many people have access to the private key in the device, I hope is 0. How many people have access to the private key in the HSM? Well, it's probably also 0, but it might actually be 4, where those are the 4 people that can reconstruct it, okay? So there's some real, I think, questions that are similar.
Okay, so maybe it is worth at least considering opening that can of worms and actually pull in the term root of trust into your document. But I'm not sure if that's useful. So just as a food for thought.
Well, okay, yeah, and it's been so hard to define it in other documents. I'm reluctant to even pick a term.
It's being covered now, I think. So I think that's not a big discrepancy with the word. But I'm relinquishing the floor to Carsten now.
So do you think that this document should go to the point of organizing this into a Yang module?
Oh my God.
I don't think so. I mean, it's just properties with keys, right? And that seems to be what 90% of Yang modules are. But I don't see the advantage at this point to doing that. No,
I would also not try that. Thanks.
Well, there is a reason that SDF is not a Yang model, but that wasn't the point I was going to make. So the reason why I think it's really worth thinking about modeling this is that in a large network, I need to find out what's in there. And as most people who actually have worked with enterprise networks know, nobody has any idea what is in an enterprise network. There are some activities like the software bill of materials and the software ID COSWID activities that try to find out what software is in there. What software am I trusting when I allow this thing into my network? And I think that having a way to document what are the trust relationships to entities that do things like certify key pairs and the trust anchors out there and so on. That may be a useful thing. So after a SolarWind thing or a Microsoft Exchange thing, I can look into my network and find out in a limited amount of time who is actually impacted by this and which part of my factory do I have to shut down because I no longer have control over it. And that's why I think modeling these security relationships is really so important.
Yeah, so I'd like to have a conversation on the list, I guess, about what level of modeling you think is appropriate, and how, you know, because what I'm hearing is that we would like to be able to point to particular profiles of this model that would be asserted by a manufacturer. We are following this model, blah, 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 and a COSWID wants to be able to point at it, or some other, an SPDX or something wants to be able to point at this. Yeah.
Yeah, but that talks about software, and software is not the only thing in which you.
It's not the only thing. I mean, it also applies to you know, the who signed the firmware in your keyboard, right, in the microcontroller of your keyboard, right? So, and did they even think that was an important key to keep private?
Right. Yeah. So there's a whole area of work waiting for us, bringing all these various models, SDF, Yang, the MUD, various pieces of MUD information that's out there, and so on together, so we can do useful inferences from that information at the security layer.
Well, I would propose that we flesh out some more bits in this document, that we think about what other questions, like the how do I explain the K of N for recovery process there, that we publish an initial document, and then we come back and discuss, well, how do we arrange this into a model that we can do this other you know, do things that are machine readable. But I really think that the ideal thing is that we be able to talk to people and say, you know, can you describe it in this, using this terminology?
Yep.
And then we can use those examples to encode our examples or use cases for the second thing. Aaron, you had no. Someone else wanted to say something.
I wasn't suggesting that all that big area I talked about needs to be covered by this document. I think that you have chosen a really interesting angle to make a crack into that area, and that's why I think it's a very useful document to look at. But I also would like us to think about the larger area and see what other components can we actually work on to make that vision of finding out what's going on in my network actually happen at some point.
Okay, thank you. I'm going to start a couple more threads on the list, but thank you for the discussion.
Yeah. So you just mentioned Aaron, probably because he just mistyped something or pressed the wrong button. But Aaron is, for instance, one of the researchers that I know who has done work in this space, and it's good to see that these people are here and looking at what we are doing.
All right, thank you.
Okay.
I have to do another talk at DNS Ops. Thanks.
Thank you. We have used up 10 minutes of our 20 minutes of flex time. And with that, the next talk is the IoT Edge challenges and functions. Xavier, do you want to present, or do you want me to, oh, you want to present? So I just press here. Oh, while we are waiting for that to come up, I have a little poll for you. So can you press the 6th button on top of your screen, the one that has turned yellow, and answer the question there. So if you know you have read it, you can raise your hand. If you know you have not read it, you can do not raise your hand. And if you don't remember whether you read it, you don't press either of the buttons. Okay, so about half of the participants has answered now, and we have a gauge. And I hope this discussion has motivated you, the ones who did not raise their hand, to actually look at it. Thank you. So on to Xavier.
Thank you. Yeah, so I'd like to present recent updates on the draft IoT edge computing. Right, so the last time we met in IETF 108, so we started the RG adoption process, and the following August, we released version 0, and a couple of months later, a minor update. So these revisions address comments from people who made technical comments during the adoption process. You know, there were two, so Marie-José and Carlos. And in this presentation, so thank you for the reviews. And in this presentation, I will summarize the update and discuss the next steps. So both reviewers recommended adding new use cases. So we added use cases on smart factory, agriculture, self-driving car, and AR, VR. Those are very high-level use cases. We also added text in the introduction about our focus on research topics rather than industry projects. So we still have like a section 4.1 that represents the current state of IoT edge computing in industry, but it does not dive into individual projects and doesn't list them. We're just trying to provide a high-level view, right? And we spend most of the rest of the section, for example, to speaking about individual research challenges. So it's more focused on this side of things. Other comments on the specific text were addressed as well. So we had an update on the description of an in-network computation, which was a bit too narrow, and we also added data discovery as a research challenge. And we did quite a few editorial changes as well. Right. So since in the next and last slide, we will ask people who are interested to provide some feedback. So I'd like to give a quick overview of the document and to highlight what was updated most recently. So of course, we welcome comments on any part of the document, on the structure, on anything you think is worth it. However, the parts that are highlighted here will benefit from most from reviews. Right, so beyond the introduction, in section 2, we have quite mature text with high-level descriptions of IoT, cloud computing, edge computing, and we have a few new use cases. Section 3 is quite stable, I think. It lists reasons that motivate the use of edge computing for IoT. It has been reviewed a couple of times. It has been discussed in T2TRG even before starting this draft, by some co-authors. So it should be relatively stable, at least. And section 4 has more recent text. So the overview part, we already discussed that earlier. It covers a very dynamic field. So people who are involved in this domain or who are interested in some part of this domain may have like good input here to maybe update some parts or improve the text there. And following that, we have a model which is very general. So we think it needs to be general to cover very different system designs in this field. However, for example, one possibility would be if you are aware of some models for IoT edge computing, which could be which could bring some additional value, we could point towards them, or could improve the model in some way. Then we have one section per function or component, and each section has a description text and a list of research challenges. So this part is relatively recent, and it would benefit from really more reviews. Feel free to propose new research areas in there, or new functions that we may have missed, or we can adapt some functions to better cover what's needed. And then we have text on simulation and emulation environment and security considerations. Right, so this is the last slide. So to our knowledge, all outstanding comments are addressed. The draft is in a stable state, and it's ready to be reviewed as a group draft. So please feel free to provide feedback, if you are interested on the mailing list, even, if you don't have a lot of time. I mean, this document is not very long, it's still 20 pages, but if you want to focus really on some parts of interest, you can just do that. And, finally, we also had a discussion among the co-authors and group chairs about reaching out to a wider group of reviewers. So either in parallel with the reviews in T2TRG, or maybe later, I don't know. A first possibility is to reach out to IETF groups. So related groups would include, for example, QuantRG and DINRG for some aspects. And a second possibility is to reach out to participants in external industry forums, through personal contacts. For example, in CMEX, there is some subgroup looking at IoT APIs, so we could do that, for example. So any feedback on this or on anything would be welcome. So thank you for your time, and that's it for the presentation is complete. Thank you.
Thank you, Xavier. So any questions to Xavier? So I have put out a poll. Again, the sixth button should be yellow on your screens, and you can go to that poll and answer my question. Are you interested in providing comments on the draft? Okay, one of the advantages of the physical situation in the room is that when you do a show of hands, you actually can see who is showing the hands. And unfortunately, with a poll, I can't, but there are 7 hands up right now, which I think is approximately the amount of review we need to get this completed. So if people could please remember that they raised their hand here and actually provide some form of review, some form of comments, that would be great, so we can advance this document. So the summary is 6 people think they won't provide comments, 7 people think they will, and everybody else is still making up their mind.
Yeah, thank you. I just would like to say, yeah, if it's even feedback on a short part of the document, it would still be very valuable. So thank you.
Yeah, so the idea is not so much that you put an item on your calendar that you do a full review of the document. That's also great, but it's also useful to simply look at an area of the document where you maybe have some previous experience with and can send some comments to the mailing list. Okay, so thank you, Xavier. We are still 10 minutes into our flex time budget. So the next speaker is Mohit on the bootstrapping terminology document. Okay, the screen share should be starting. Do you have to press a button on your side? Ah, great.
Hi, can you hear me?
Yes, thank you.
Excellent. So I just finished Sec Dispatch and joined now. Sorry that I was in two places. So yeah, I'll be presenting our draft on secure IoT bootstrapping. We started this as a survey, and I'm Mohit. This was work done together with my co-authors Bechet and Dan and various other contributors. So just to recap, this draft was, well, exactly like 5 years ago, version 00 was submitted. So in March 2016, this has been around for a while and obviously has been undergoing changes since the beginning. So we have added definitions, classifications, and the new part added in the last year has been the bootstrapping terminology. So a lot of the contents were written even before many of the protocols that are being developed now existed. So I'll be presenting version 11 of the draft today. So one thing we wanted to cover in this draft is that there's various terminology that is kind of interrelated and is used a little bit freely, although we are not sure we completely understand the relationship between the different terminologies and how different standards bodies are using those terms. So one of the goals of this draft was to find the terminology and then also try to document what other terminologies used by the different SDOs, including IETF, but also outside the IETF. So here's a list. I might have missed, but I think this is soon getting exhaustive. So we have bootstrapping, provisioning, onboarding, enrollment, commissioning, initialization, configuration, registration, and discovery. And in the next few slides, I'll just be going through some of the example protocols or systems and what kind of terms they are using. So the first one I have on the list is DPP. Hopefully some of you know Wi-Fi Alliance Device Provisioning Protocol. I saw Dan as one of the attendees, so he's, I guess, one of the main authors of DPP. Hopefully, Dan, you can correct me if I have not written the summary correctly, but DPP, at least in the spec, has the following three sub-protocols or phases. The first is bootstrapping, where basically you obtain the public key of the other party. So this can be through scanning a QR code or tapping NFC or some other form of out-of-band communication. Once you have done that, you can do authentication. So there's at least authentication of the responder to the initiator, but optionally there is also mutual authentication. So if you have scanned QR codes in both directions, then you can get mutual authentication. There's a couple of different terms used in the spec. So there's the configurator, enrollee, enroller, and there's the initiator and responder. But I guess the important ones are here colored. So there's the bootstrapping authentication and then the configuration. So once the parties are authenticated, the configurator, which is typically your smartphone application, can send information such as the SSID and passphrase to the new IoT device. Then the draft also covers OMA lightweight M2M. So OMA's design is basically a new device contacts a bootstrap server, which is responsible for provisioning information such as credentials. And once the device receives these credentials and information, it then registers itself to one of the lightweight M2M servers, which will then manage the device during its life cycle. The specification defines 4 different ways of bootstrapping. You have factory bootstrap, where like the credentials are already pre-provisioned into the device at the time of manufacture. In that case, the device doesn't really need a bootstrap server. It can directly contact the lightweight M2M server. Then there is options of bootstrapping through a smart card. There's client initiative bootstrap and server initiated bootstrap. In the draft, we have also written about OCF, but I thought for brevity in the presentation, I'm not presenting the terminology used by OCF here. Instead, I thought it might be interesting to cover what FIDO is doing. So FIDO Alliance has automatic onboarding protocol and is using lots of IETF specifications like EAT and CBOR. So basically, what FIDO is trying to do is provide the IoT device with sufficient information so that it can interact with an online cloud platform, typically hosted in a cloud. So think of some Amazon or Azure platform. But my understanding, at least of reading the specification, is that the problem of network connectivity is not really solved by the protocol, and the protocol assumes that the device has already joined the network. Joining the network doesn't necessarily mean that it has joined the internet, but at least it has some network connectivity. One of the features that FIDO Alliance claims to bring to the table is late binding. So basically, the concept here is that owners of IoT devices can choose the platform to which their device would connect to at quite a late stage in the device life cycle. The protocol is, again, as you can expect, is composed of several sub-protocols. So there's the device initialization protocol, which is executed in the factory, and here the initial ownership and manufacturing credentials are placed typically in a secure storage like a TPM. Then you have transfer of ownership protocols, and there are 3 of them. So here they are written as TO0, 1, and 2, and these protocols occur between the device, a rendezvous server, and an owner onboarding service. And the whole idea is that once these transfer of ownership protocols are completed, the new owner of IoT device and the device have authenticated each other. And once this authentication is complete, the owner can obviously provide cryptographic information and URLs to the device of the IoT platform to which it should connect. So these were some of the standards work that is going outside the IETF, but obviously we have lots of bootstrapping related protocols that have been developed at the IETF. So we have EST. I'm sure some of you are familiar with enrollment over secure transport specified in RFC 7030. It's a profile of certificate management over CMS. If you are wondering what is CMS, it's cryptographic message syntax. So many new acronyms to learn here, but the idea is simple, that client devices can obtain client certificates and associated CA certificates. And originally it was specified with interactions over HTTP, but thanks to the EST working group, there is now a companion specification that defines how EST can also be transported over CoAP. One interesting thing in RFC 7030 is it allows you to bootstrap basically devices which have minimal configuration. So if you have no credentials on the device, then you can rely on the human user. And the idea here is that the human user can verify information such as the CA certificate with a fingerprint shown over an authenticated TLS channel. So you can set up an authenticated TLS channel and show the user that this is the CA you are interacting with. Do you want to request a client certificate from there? And after successful bootstrapping, you can proceed with enrollment. There's also Brewski, so bootstrapping remote secure key infrastructure, which uses 8021 AR vendor certificates on the device, and the device performs several steps. So first it discovers a registrar, it identifies to a registrar, then it requests to join. If the registrar has the needed connectivity to the MASA, MASA is basically something that is hosted by the manufacturer. It can imprint and then use EST to actually get certificates and enroll. one thing that Brewski does in addition is that it can work with link local connectivity, and it doesn't really require a routable address. However, as I stated, there is this need of having a MASA, which basically is a internet-based service that the typically device manufacturer would be hosting. Not necessarily, but at least someone should be hosting this MASA on the internet. And finally, we have SZTP, Secure Zero Touch Provisioning, and the RFC 8572 calls it a bootstrapping strategy, which enables a device to obtain bootstrapping data with no to minimal installer action. The RFC defines several ways of obtaining this bootstrap data. So you have DNS, DHCP, removable storage, or from a bootstrap server. The draft also uses the term onboarding server. Sorry, I should not call it a draft, it's a RFC. So the RFC also uses the term onboarding server, which is basically a bootstrap server that returns onboarding information. There's also something called as a redirecting server, but I thought that was not so important to cover in the slides here. The idea is very simple, that if you receive some information that is untrusted, then either it has to be signed or it can only be processed provisionally. So you can either be redirected to some other place, or you should receive information that is signed and you can verify. So now that we have seen all this fancy terminology in action, how the different SDOs are using it, so what was the key lessons or takeaway from this? Well, at least our understanding is that there are several stages before a device can become fully operational, and this typically involves establishing some initial trust, after which you kind of provision or configure the device. So, for example, in DPP, bootstrapping is the first step, then there is authentication, and then you provision credentials onto the device. Similarly, in EST, bootstrapping happens as the first step when client has no credentials available, but once there are some credentials, you do the enrollment and receive certificates. Obviously, some protocols only deal with parts of the process, whereas like some other SDOs build entire systems where you not only provision credentials, but you provision access control lists and so on. So OMA, for example, is something that not only is provisioning URLs and credentials, but also access control lists and other types of configuration objects. And here I have just one example of a protocol that uses TLS and does bootstrapping, but then leaves the provisioning of access control lists to another protocol. Please join the queue. I can't see the queue, but feel free to stop me at any point. There are slide numbers, so hopefully you can always take me back to some slide if you have questions. So the draft doesn't stop here. There's after all this terminology discussion from various SDOs, we try to do a survey. An obvious problem with writing surveys is like there's tens, if not hundreds, of protocols and specifications to cover. So you don't try to cover all of them, but rather try to classify them. So the draft currently has this classification technique where we classify things into managed, P2P, and ad hoc, leap of faith and opportunistic protocols, as well as hybrid. And one of the key takeaways is that obviously categorization is not always easy or clear. So protocol might fall in some version, it might fall in one category, and in another version, it might fall in another category. But at least it gives you an idea of trying to classify different protocols in different categories. This is our last slide. So obviously this draft has been here for 5 years, and the authors think that it's very far away from publication, but super ready for adoption. And one question is the title reflective of the content? Because now it's not just a survey of bootstrapping protocols, but also of bootstrapping terminology and it goes a little bit beyond that and tries to understand the relationship between the bootstrapping terminology. With that, this is my last slide. I'm up for questions.
Go ahead, Andre.
Thank you, Carsten. Very, very interesting talk. As I was listening to this, I couldn't help wondering whether there's been any thought about the performance implications of enrollment and onboarding, and whether if people have thought about the performance requirements for these, for different kinds of devices. I could see a scenario where a device fails and you need to bring a replacement on very quickly. But if the enrollment time is an hour, that's not so good.
Well, at least this draft has not taken any position on any of those aspects. So as from my slides, it was evident some protocols require a human. So if you're scanning a QR code, then that's a different user experience than, let's say, for example, zero-touch provisioning, where there is no human, and the costs of failing and retrying obviously are different, whether you have to take out an app and scan again, or whether you're just retrying on the network. But at least this draft has not gone into trying to distinguish those aspects. We might run into problems in trying to do that, especially if we actually run prototypes and try to collect actual data from the network. I'm not saying it should not be done. It would be pretty interesting, but so far that draft has not done that.
Thank you.
Aaron?
Okay, yeah. Can you hear me now?
Yes.
Yep.
Oh, okay, yeah, Mohit, very nice work. So I have been actually following these parts for a while. I noticed that in the recent versions, there is a Bluetooth section you added there in, I don't know, since version 6 or somewhere. But then it has been there for a while. So I was wondering, since you want to bring this further, it's a nice work. But then at which point you would like to say, this is sort of like, the somehow phrase is settled here, like this Bluetooth part. I'm interested into what you are going to add there, but then, yeah, since it has been there for a while, what's the latest view from your opinion?
It's just, I guess, lack of time on the authors. So I have materials. I have studied Bluetooth mesh and how the provisioning works there. It's just finding the time to write it, and I promise if this gets adopted in the version that is the research group version, there will be text on Bluetooth as well.
Oh, okay, good. Yeah.
Okay, so I take it, Aaron, that you would be able to provide comments on a Bluetooth section?
When there is content, I can provide. The current one has 3 lines or 4 lines, so.
Yeah, the current text is just to be done, so I promise to add that.
Great.
Sorry, Carl, go ahead.
Yeah, if there are no other questions, let me do my usual poll thing. So again, are you interested in providing comments on this draft? Oh, nobody is not raising their hand this
I'm
time.
not so much interested in providing comments as in aligning our standards with it. We've also been struggling with defining, life cycle, and this provisioning, onboarding, bootstrapping, these terms and the definitions have been a sticking point. So we'll look at it from that point of view, at least aligning terminology. So the question is, how stable is that section of the document? Like if we align and you change it, it'll be kind of a nuisance. So.
So Maud, what's your view on the stability of that part?
I think the summary of the different SDOs is stable unless the SDOs go and change their specs. Obviously, the takeaways is something that is currently the author's reflection of understanding that that generally there is this bootstrapping phase, which is then followed by provisioning and configuration. But once this gets working group adopted, then it's the working group or research group's understanding of what are the key lessons or takeaways. But I feel that part is stable, and please find time to read and provide comments.
Okay, so the result of the poll was that there are 8 people who are interested in providing comments on this document. So that's a significant level of interest. So I'm not going to start another poll, but just to get a sense of the room. If you are opposed to the idea that the research group could be adopting this document, please speak up now. So as usual, we are going to put an adoption call out in the mailing list, but that's at least useful level of interest, and nobody is opposed. So I think we have good chances to complete this affirmatively.
All right. Well, I
Any
see
more?
Dan supporting, so thanks.
Any more comments for Mohit right now? Dan says adopt. Thank you, Dan.
Well, all right. Thank you for your time. I look forward to your comments on the mailing list.
Thank you. So we have 8 minutes left, and it's time for a wrap up. Any other things that people want to bring up? So this should be the point where the chairs point to all the wonderful things that we will be doing in the next time. And much of this actually depends on getting feedback from the research group. So we have seen 3 drafts actually could use feedback at the moment. Please go ahead. Short notes are useful. Longer notes are also useful. And we will have our regular Wishy calls again soon. Anything else I should be mentioning, Ari?
I guess that's a good overview of the upcoming activities. And as usual, follow the T2TRG mailing list. We'll be posting their information if there are new activities coming. And as always, we're always looking forward for more collaboration with the academia. So if you are perhaps organizing some academic events that are kind of in the same area as we have in the T2TRG research group, please approach us chairs. We're more than happy to have a discussion with you and do things together.
Thank you. So I think with that, we can close the meeting. Thank you for your participation. Thank you for the great talks. And see you at one of the ad hoc meetings or one of the Wishy meetings we are making, and otherwise at IETF 111's summary meeting. Meetings adjourned.